All right, so we've been talking about perimeter and area again, and we are going to just revisit this for triangles and rectangles or four-sided shapes. So, number one, perimeter. So we're looking for the perimeter and then we're looking for area. And perimeter is when you add all the outside lengths together. We will not be using the height for this one, so perimeter. So I'm just going to write it here. So if this is 4, this will also be 4. And if this is 5, this will also be 5. So this is 4 times 2, because there's 2 of them, plus 5 times 2. 4 times 2 is 8, plus 5 times 2 is 10, which gets us to the perimeter of 18 centimeters. Okay? You don't square your centimeters. Your perimeter is just your regular unit. Now for area, it's base times height, because this is showing, even though this looks like a triangle, we have 2 and this is actually a four-sided shape. So we're actually just going to do for the area base, which is 4, and we're going to multiply it by the height, which is 3. And you'll remember we're looking for that 90-degree angle coming off of the base to measure our height to the top line, or vertical point. Vertice, if you really want the right word. 4 times 3 is 12. Now, this is the part where it is different. Because we're measuring area, the inside, we are looking for centimeters squared. All right, next. Perimeter. They have to give us all of them now for this triangle. 4 plus 13 plus 15. 4 plus 13 plus 15. 13 and 15 is 28, plus 4 is 32. 28, 29, 30, 31, 32. 32, and because we're measuring perimeter, we leave our unit as just by itself, so centimeters, not centimeters squared. For area, though, we are going to go base, which is 4, and we're going to multiply it by the height, which is at a 90-degree angle to the top vertex, which is 12. And because this is a triangle, we do have to divide our area by 2. So 4 times 12 is 48. 48 divided by 2 equals 24. And that would be 24 centimeters squared, because we're talking about area. Perimeter, area, perimeter. All right, next one. We're doing another triangle. So again, for the triangle, for perimeter, we're adding all of the outside lengths, and then for the area, we'll do base times height divided by 2. All right, so perimeter, 14 plus 15 plus 13. So 14 plus 15 plus 13 equals 10, 20, 30, 38, 39, 40, 41, 42. Centimeters. I didn't give you this as an answer page because I wanted you to listen to the directions. I really want you guys to slow down on these. Area. Area is the area that we're looking for. This one is a triangle, and it means that we will do base times height divided by 2. So base is 14 times the height from that 90-degree angle to the top vertical point, which is 12. And then we're going to divide it by 2. So 14 times 12, well, 14 times 10 is 140, and 14 times 2, which would get us to the 12, 14 times 2 is 28, which gets us to 168. And now we have to divide that by 2. So 2 goes into 16 8 times. 2 goes into 8 4 times, which is 84. And 84 centimeters squared, because we're talking about area. I do, sometimes I remind kids when you're doing this, well, I won't go there. Anyway, it's just good practice. Next, we're doing base times height. This is a parallelogram. A parallelogram has 2 sets of parallel sides, and this is a trapezoid. So it doesn't have any 90-degree angles. So here we're looking for all of the lengths on the outside, and as you can see here, it's 7, 7, 7, 7. So we could do 7 times 4, which would be how many sides there are. It would get us to 28 centimeters. And we're not going to label it squared because we're not talking about area. Again, we're talking about the perimeter, the outside. And for area, we're talking about the inside. So we're going to do base times height. And again, they're just looking for that place where you get the 90-degree angle and the top vertical point. So 4 times, 7 times 4, and because it's a 4-sided shape, we don't have to divide, equals 28 centimeters. This will be squared because it's area. All right. Now this next one, choose a base that and a corresponding height with lengths you can find without a ruler. Then find the area. Each square represents 1 centimeter. So they're just saying use the squares. They don't actually want you to count all the triangles and the squares. They just want you to go, so this is our base. Our base equals 1, 2, 3, 4, 5, 6. Our base equals 6 centimeters. And then our height, because we're going from the base, and we'll make that will be our 90-degree angle. Our height would be 1, 2, 3, 4, 5 high. So our height equals 5. So our area is our base times height, which is 6 times 5. And this is a triangle, so we would be dividing it by 2. So 6 times 5 is 30. 30 divided by 2 is half of 30, would be 15 centimeters squared. Again, you're seeing me not use a calculator. I could show you that you could put 30 inside. So in front is your numerator, inside is also your numerator, and divide by 2. 2 goes into 3 one time. Subtract 2 from 3, which would get you 1 left over. Bring your 0 down. How many times does 2 go into 10? 5 times. And that's where we get that number. Next, we have this is wanting us to use centimeters, so the base is 1, 2, 3, 4. So base equals 4 centimeters. And then our height, remember, our height is, you can do a line over like they do, and then do a line up. And then we're just looking for the height from this right angle. So 1, 2, 3, 4. So the height equals 4 centimeters. So this is the area of a 4-sided shape. So we would actually do base times height, which is 4 times 4. Which equals 16, and because we're doing area, it would be centimeters squared. All right. This next one confused me because I just so you know, they say the baseball diamond has an area of 3,600 square feet, or feet squared. What is the distance between each base? Well, if you know baseball is 90, but this is actually giving us a different number. If it was a real baseball field, like a full-size baseball field, it would be 8,100 square feet if you were actually really doing the true measurements. But we're going to pretend like maybe this is Little League. What is the distance between each base? So we need to know, we have 4 sides. We need to know what number goes into 364 times. Well, you could say 9, but what you have to remember, the same thing is that when you're doing that measurement, it can't be 9, because if you do 90, when you do the area, it's base times height, which would be 90 times 90, which would be 8,100. So even though it has 4 sides, you're looking for a number when you're finding area where a number times itself to get 36. So here you're actually looking for not a number times 4, you're looking for a number times itself to get you to 36. And the only number where a number times itself gets you to 36 is 6. So 6 times 6 is 36. 60 times 60 would be 3,600. Now it says, what is the distance between each base? Well, the distance between each base would be 60 feet. How 60 feet between each base? And then it says, how far would they have to run if they ran all the way around for a home run? Well, 60 plus 60 plus 60 plus 60 will be 240 feet. Not squared, just feet. Next. A postcard in the shape of a parallelogram has an area of 12 inches squared. What are 2 possible lengths of bases and heights for the postcard? So they could actually ask you for more, but they're talking about postcards. Most postcards are rectangular and they're fairly fat. So we're looking for numbers that could go into shapes like this that would get a total of 12. And so you could think of 2 and 6, 2 inches and 6 inches. Or you could think of 3 and 4, which obviously they would not even look remotely as close. My argument is if you had a 2 by 6, it would actually look more like this. And a 3 by 4 would actually look more like this. But then if that's the case, why don't you just have a 1 by 12 inch postcard? Literally, because it's might as well have that as a choice as well. So what are the 2 possible lengths of base and height for the postcard? So it's 2 feet and 6 feet. What kind of postcard are we sending? 2 inches and 6 inches, and we'll let them be right and do 3 inches and 4 inches. So it depends, because you could do 12 and 1. All right.